tidy up a little bit. Need to change that bag out. Alright, let's see what happens when people show up. This is a 4-aught harness, just so you guys know. This is just some ground clips. I do my connections different than other people. Some people like to solder. Excuse me, some people like to solder, some people like to crimp, some people like to do both. I like solder because it's the best electrical connection. You can definitely change up and wire a setup with both, but you need to have a good crimp tool. Don't just be having some cheap crimp tool. Good crimp tools cost around $3 grand, so I don't really think my customers want to have to pay that much, so I don't think I'll do that. I could always rent one for time periods, but then again, same thing. Don't want my customers to have to pay for that. So,
how do you have so many watchers already?
They coming to check out my stuff. They in and out. Hello, hello, whoever's on there. Hey, Rocky and a few other guys. Yeah. This is some fairly large wire, just so you have an idea what size it is. I'll try to get you a comparison. Will you grab me that red wire over there?
The one that's all tangled up underneath the other wire?
Yeah, just snag what you can. No, small red one right there. Yeah, yeah. Snag what you can out of it. If it don't come all the way, we'll put the rest back. Don't worry about it. It's just for an example. And there's a wire that's a little bit bigger that's sitting over there that's tying those two quick disconnects together. Will you hand me those? That red one?
Yeah.
You have to go around the long way.
I don't know what you mean by the long way.
Well, around the batteries.
This way?
But just to give you an idea, guys, this is a 4-gauge wire right here. And I'll go up to the next size. 8-gauge wire is smaller. I don't have any 8-gauge, but just to give you a kind of an idea. 8-gauge wire.
This one?
The bigger one.
This one?
Closer. No, it's right next to the spool. You touching it? Yeah, that's it. Snatch it up. Pull it out. There you go. Alright, so there you go. Kind of give you all an example. This is the equivalent of basically 8-gauge wire. It's not 8-gauge specifically, but it's that same size. The next size up is going to be 6-gauge. Not many people use it. The next size above that is 4-gauge. I say it's about the size of my pinky, but technically it's smaller. But just so you know. Next size above that is 2-gauge. Again, not many people have that, but it's still used. This is 0-gauge right here, or technically 1-aught, since 0-gauge doesn't really exist except for outside a car stereo. Much bigger than my pinky. I'd say it's about the size of my thumb, just to give you kind of a reference. Next size above that is 2-aught, 1-aught, 2-aught, and 3-aught. 2-aught's bigger than 1-aught, 3-aught's bigger than that, and then 4-aught is this stuff right here, just to give you an idea of reference. Let's go back to 4-gauge, which is good for 100 amps. This is wire all the way on the bottom. So this wire is good for about a 100 amp circuit. So just to give you maybe a focus, we'll see what happens. Focus.
Put your hand behind it.
It's focusing on me.
No, behind the wire.
Behind the wire? We'll see what happens.
So it doesn't focus on your face.
I can't do it.
Get tried. Get it closer to it.
We trying to learn some camera knowledge here. It's focused on me. Whatever. Y'all got an idea. Who cares?
That's what the makeup people do. They
Yeah,
hold it up with their hand behind it.
Yeah, I don't care about no makeup people. We learning how to do Facebook crap now. Alright, whatever. But yeah, there's your cross reference. 4-gauge, 1-aught, 4-aught. So, much bigger wire, just to give you a kind of reference. Much bigger tools required for the bigger jobs. But what I'm doing on this is soldering them. Like I said, you'll get the random keyboard warrior that says, oh, you need to have a crimped and solder connection for the best connection you can do. You need to have a crimp connection for this. You need to have this for that. Let's just go ahead and tell you, crimp is the best mechanical connection. Solder is the best electrical connection. A combination of both is a very nice connector, but also a very expensive connector. So I'm trying to appeal to the average budget, so there you go. This is a double jacketed wire right here. I have multiple single jacketed. I just felt like being nice to this fella and giving him the big double jacketed wire that I've got, because he's going to be using it in multiple applications that he requires but it works out to be nice. There's not really any need to have a double jacket. It's just extra overkill kind of stuff. Okay, that's fine. Figure out what's going on.
See you in 3 hours.
It won't be that long. Alright, what I'm doing now is just stripping the jacket back. It takes a bit of work to strip this jacket back because it's not a single jacket. Just to give you an idea how thick the jacket is, you'll see it in just a moment. Alright, so let's see how much trouble I have with this. Oh yeah, that'll be fine. Still gonna be stout. Alright, that's a 4-aught terminal. It's all copper. And that's the jacket thickness. It's literally a double jacketed wire. Stupid camera won't focus on me, but I ain't doing none of that stick your hand up crap. If y'all don't see it clear, I'm sorry, but that's about all you'll get from me. Alright, so pretty much whenever I put this wire in, it's kind of tight, so I'll have to be careful with this. See, it goes on, but I'm probably going to have a little bit better vise than what I've got currently. But this is generally the main reason why most people will build the weep haul option. So what they'll do is do a connection like this, they'll crimp it in, they'll cut a hole in here, right here, and they'll solder it. That way they can stick some wire in there and solder it. So let's just kind of show you. I'll show you that method. We can do 100 different methods to make this work, but I mean that's just one to show you. And this wire is tight already, so it would be difficult to show you my other method without my tools. So I'm gonna be right back and grab something. Actually, no, it's right here. I actually cleaned up my mess, so I got a few drill bits right here in front of me. That's a drill bit, not a drill bit. That's the drill bit I need. So here's a drill bit set. Let's go ahead and do a fairly large hole. This is a method that most of you can copy much easier than the other method. The other method's going to be much more difficult for you. So it also works out for you guys. I don't have that drill in front of me and I don't feel like walking, so I'm going to use my other drill bit set. So here we go. What I'm doing is just anything to allow a good portion of solder to weep in at the same time as doing this connector. And I have 30 of these connectors, so it's not really very critical for me. There you go. I'll pull this out, pop this through the rest of the way. Again, be safe whenever you're doing this, because this connector can kick off on me, and if I'm not careful, I can drill my hand. So if you're not confident with a drill or anything like that, make sure you always just prep with something else. Get a vise or something to get you safe, keep you safe. All right. This right here is going to be more of a boring process than my main process that I do. Basically what I'm doing is try to preheat this. Normally what you do is, I can do it like this. Got a little heat gun. This is 450 degrees, so you can kind of just heat it up as you go. You can use whatever you want as long as you got the right tools. Don't do that. But I didn't have an extra hand, so that's why I did it. I'm using this kind of like a hot plate. If you've ever dealt with anything SMT, that's what they do. And what I'm going to do is wait for this to get hot enough to wick in. Y'all didn't get to see my cool method. My cool method's a torch, but I don't have a big enough vise to do this with a torch. So what I'm doing is just waiting for the solder to wick in, and pretty much that's the gist of it. Pop a hole, wick the solder in, there you go. What's up, D-Man? Waving a hand. And what gauge wire would I use for 250 amp? The gauge wire I use for 250 amp would probably be dependent on the length. How much length do you want to run it on? So that's the first thing I would need to know. So if it's going to be short length, I mean, you could run 1/0 and be fine. But if you're going to run a 10-15 foot piece, then you'll definitely need to run a much bigger wire. So what I'm doing is just literally adding solder as it wicks in. Let it wick in. This is kind of the lazy method for me, just having this hole big enough to fit my soldering iron in. Some people do small wires or small holes. But I'll just keep adding solder until it wicks, and then I'll be able to look inside that connection and look and see what it looks like. Right now I've got much more solder to add. And I'm going to test out a method. We'll see if this works. I doubt it will, but I've never used this method specifically, but I'm kind of curious how hot it gets in there. Not quite hot enough. 450 degrees is not really enough to do what it does. What I'm doing is preheating with this temperature and then allowing the rest of the heat from the what's up, little retard in the yard, waving a hand, man. So this is kind of a method that anybody can use. You don't have to be good at soldering. You don't have to have a good vise. You don't have to have good equipment to do this method. And it also makes sure that you're going to solder properly. So I'm kind of working myself out of a job, but I don't care. You guys can kind of do whatever y'all want. I got the wire. I can always provide the supplies. And you got to watch out with this. See, the heat guard that I got on here is actually blowing heat back on my hand, so I have to keep myself far enough away so I don't burn myself. But yeah, I just keep adding solder until I'm ready. Now, you could do this with like a Chicago Freight or whatever, Chicago Electric from Harbor Freight heat gun. It don't really matter what kind of heat gun you use. You don't have to have no expensive piece. And you can kind of see just an idea of how much solder this stuff eats. It literally just eats a bunch. 8 to 10 foot from the battery to the dash. 250 amps, you could probably get away with a 1/0, but you can expect voltage drop. If you wanted to not have any voltage drop, just go ahead and go 4/0 and be done with it. I mean, that's really the point. It depends on what kind of voltage drop you're looking to have in your application. You're on a super cap, you don't have to have big wire, but then at the same time you can't recharge as fast without the wiring that you need. So it's best to go the wire and the alternator and be done with it than it is go like some sort of band-aid. A super cap is a really good band-aid, but it's still a band-aid, so it's always best to use the right size wire for the job. So pretty much this is how long it takes to do any of these big connectors, big wires, or anything like that. So you guys expecting to do this project in like 5 minutes, it's just not going to happen. But it's not too bad. I mean, literally, this is something you guys can kind of do easily. Size your stuff properly, and just be done with it. I mean, you won't have to worry about whether or not you got enough or something. Most of the time, anytime somebody ever runs an amplifier and says, "Oh no, this amplifier is not doing the watts that I wanted to do," either they're running one, the wrong combination into it, or two, they're running a improper connection. Like their feed point connection will fail, or not feed point connection, but their terminations will fail. Like when they build this connector right here, they'll try to do some crappy crimp and it won't hold. So this just gives y'all an idea. This is one method right here. If I got enough, if I can find a vise over here somewhere that I can work with, I'll show you my other method. But otherwise, I'll just do this. Alright. Now, what I would like to do is be even lazier. And what I would have to do is come up with a zip tie to hold this trigger. All it is just a matter of replacing batteries when they die. but I don't have my toolbox near me, and I would have to lose my progress on my heat. So, thing you'll have to watch out for with this is keeping your soldering iron out enough to the tin side. Yeah, to this tin side to actually bond to. Like if you're trying to touch the outside of the soldering iron, it's not going to burn properly. It'll just bead off. It won't actually wick in. So if you got a soldering iron that's a decent size, this will work. Yeah, I'm sure you see it all the time, Danny. All sorts of stuff. But yeah, this is just 4-aught. It's just a. This is the longer method. If I do it with a torch, I could probably have it done in maybe 3 or 4 minutes max. This method right here takes much more time, but it also works at the same time. So it's also another method to work. Especially when you don't get the right size connectors. Like this size connector right here is a 4-aught connector, but this wire is over-specced, so it barely fits the connector. So when you have over-spec wire or just the right spec connectors, then you'll have to do this method for tight connections. If you have loose connections, you can kind of do the other route and get away with it. Well, this is what a lot of people do, and you got other connectors you can use too. I'll show you all them. They're used in the multiple other industries, a lot of times to do with power or electrical or even telecom and stuff like that. They use these other styles. They have a hole already in them, and they're designed for crimp. So now I'm picky, so I'm gonna have this heat on this thing for a long time. But I mean, I could technically stop right here, and I would have enough bond to grab the wire. And the way I'd check is just simply look in my hole and see how much solder I've got in here. And me personally, like I said, I'm not one of the ones to skimp, so you'll see me continuously loading something when somebody else would stop. Because what I want to do is get a full bond around the jacket of the wire, because that's where a termination will fail. And if you see, what will tell me that my iron is not enough to keep this up is if my iron starts getting sticky, and it's not. This iron's plenty enough for this job, along with preheating the terminal. So what I'll do is look in here and see what kind of bond I got. I wish I had just a little bit higher stand than what I do. And then just keep adding. It's kind of a boring process. Big wire is nice to see, but it's fun to build. So anybody who's ever building something large and you said, oh man, I had a ball building that wire, I might call you a fibber or something. I mean, who knows, you might like it, but it's not necessarily the easiest thing in the world to build. I'm gonna kind of cheat right here just because I want to. Same concept. This is a torch. You can do the same thing. So you have to watch the jacket of the wire whenever I'm doing it this method. There we go. Woohoo! So now from this point, I just put a piece of heat shrink over it, covered that connection up, and now it's all nice and bonded inside there. Any extra solder, I just beat it out. It don't really matter if it's in there or out of there because it's not really doing anything for me. And then I just get a nice piece of heat shrink and cover this up. I do have some heat shrink, so I kind of will show you that since I've got it. You think, oh man, what kind of heat shrink it takes to run that? That's I like that size. I've got all the way up to that size. Finally got me some scissors. For you guys that's been following for a while, I've been slacking on my scissor approach. And then once this is bonded, cover it up. Try to cover it up fast because how hot this is. I don't have anything to cool it off quickly, so what I'll do a lot of times is whenever this doesn't go on immediately and doesn't fit, this thing will start heat shrinking down, so I let it cool off off to the side of me, and try not to burn myself by leaving it out where it can touch my leg. So here's the next one. You'll see how it goes. It'll probably go faster with the torch method. I figured out a method to show you guys without a vise, so I'll let y'all see it. You can see kind of how long this video is gone, and you'll kind of see how long it takes with this next piece, and y'all can kind of time me and see what it takes. So here we go, next one. Basically just measure it with the terminal itself. This is double jacketed wire. It is not easy to cut, so make sure you have a good blade and you cut it well. So watch me have to cut it again. Yeah, I've got mostly through the outer jacket, and I'll have to hit the inner jacket next. Alright, off. It's not for the faint of heart working on wire like this. You think little wiring harnesses are difficult. Try this stuff. Alright, so here's the next one. Kind of show you what's going on. So I slide it on over this connector. I gotta twist it because it'll try to buckle on me, because it's, like I said, this terminal's literally the very limit of what this wire can hold. What's up, King Snake? Waving a hand. BBI gave me a shout, so that's cool. I hope everything works out great with that. I didn't call you back. There you go. Got my hole. Now we'll cheat and use a wire. So let's kill this soldering iron real quick. So now with this method, you can run pretty much any torch you can find from the Home Depot, or pretty much wherever you want to find one. You got something that's not crazy temperature. You don't want to use MAP. You probably want to use propane. Propane's plenty for what you need to do. But yeah, here's this method right here. I'm just OCD. I don't like that stuff. You'll never see it, but I do, and it bothers me. I'd say this method's probably the sloppier of the two methods. But it's also more effective. I like this method a little bit better because it actually bonds faster. It allows the copper not to get too hot. What happens when you wait a long time with connectors like this is the entirety of the wire will get hot, and if you have a weak jacket, the jackets will melt on you really bad. So if I had to recommend an option, I would probably recommend an option that's higher heat, shorter duration, because copper is really good at passing heat. It'll wick the heat down the wire before you have enough chance to warm up the connection, and you'll have to add more heat to kind of compensate for that, and it's kind of a cascading kind of failure situation. So if you got a weak jacket and you don't have a double jacketed wire, your connection may end up giving you trouble before mine would, because this wire's not cheap. So I'll try to do another terminal on this other one while the other one's cooling off. See if I can, or excuse me, heat shrink while this other one's setting up. Same kind of concept. Oh yeah, somebody told me I needed to get a heat gun. I got one. It just takes more time for this bigger stuff to shrink down, especially the stuff that's got the See, me personally, I'm not a fan of just sitting here for 5 minutes waiting on a heat gun to cool off or shrink my heat shrink all the way down.
Yeah, that's handy.
Yeah, it's not that handy, not for what I do. See, look at that. I mean, that's why I don't use a heat gun, just so you guys know. Even though I own 2 of them. Just shrunk right down in just a second. Use a heat gun if you want. Don't make no difference to me. I mean, it's not no skin off of my back. Hello. Say hi. No, you can't be touching that. That's hot.
They took that.
Say hey. Hey, hey. Say hello. Alright. That's my littlest helper. She don't do much helping yet. What? That's not hot. You can see that. Copper. She's starting early. Any sort of wire like this has got flux in it. So the reason you use flux is to clean the material that you're using. If your material is dirty or old or anything like that, yes, you would gotta get into using flux. But the reason that you use flux is very simply to clean the metal. It's not to bond the solder or anything else. A lot of people get that confused about what flux actually does for you. But yeah, I'm still using a flux cord wire. I mean, you're not, every solder's got flux in it unless you buy just straight lead solder. Somebody says hello. I said hey. Hey. There you go. She said hey back. All right. Next one. Don't be eating copper. I don't think copper's bad, but still high amounts of copper. Not so good. So, anybody's got any questions while I'm doing this stuff, feel free to ask. Power related, whatever, don't really matter. It's just, like I said,
Uh-oh.
it's okay, don't worry, I got more. Alright, so next is this one. Yeah, if you saw what I was wiping off, that was actually rosin core flux that I'm actually wiping off.
No, it's not coming.
Alright, give me I need you.
Just look under my watch.
Yep.
Just let me know it's not on.
Okay. I got one more terminal to do, then I'm done with at least part of this. This is both the ground wires for the main automotive install, and then when we get to the rest, we'll do it later. So, heat shrink again, same thing. Kind of catch.
Look, I dropped it again.
All right. So I'm about to use the torch.
I was just trying to give that to you.
Thank you, baby. Alright. I've been touching lead, so I explained on this video why I don't use a heat gun, just so you guys know. You can kind of see how long I spent on that other piece versus how long I just spent doing that. So.
It's really close to your phone.
It always is. Everybody looks at it and like, oh no, you're gonna burn yourself. No. Sorry, I haven't burned myself yet. Not with a torch, at least.
No. No.
Alright. Yeah, the 4-aught positive will be... I do not have a lot of red, but yes, 4-aught positive will be red. It'll be double jacketed the same way as the other one. So that's some 4-aught wire. No, you can't sit with me, little girl.
But this is our sitting time.
What? What? She's saying hello and she wants to see what I'm doing, but she got to stay back. It's hot. It'll be away from her. This is, I just did this method today. I do another method.
I know you usually do it for...
Yeah, use it with a vise holding it or something. This is a weep hole method. I don't care. See, this terminal is really tight on the wire, so I need to make sure I go with that method.
Alright, tell them bye. Please
Bye
say
bye.
bye. Say bye
Bye
bye. Bum kiss him. Mwah. Mwah. No. Say mwah.
One more to go after this.
We're gonna go with him. Have a good time? Yeah? Okay. Okay, tell them bye. Bye bye. Can you like this?
Tell them bye. Say more.
Bye bye. Okay. Say bye bye, Dada.
Bye bye, baby.
Say Daddy bye. What? That wasn't part of the deal.
Oh, crap.
Daddy will be in a minute.
It'll happen eventually. Whatever. I got. Alright, so anybody has any questions, feel free to ask. Not really nothing much to tell you about what's happening here. That's the flux coming out. Somebody asked if I didn't use flux. That's literally flux coming out of the connector. So just so you know. Pretty much what I'm doing is this is a method for use whenever you use too small of a terminal for the job. This is not too small of a terminal. This is actually an over-spec wire is what it comes down to. But when you can't fit the wire in the terminal the other way, you can do a weep hole method like this. And also if you're trying to do a combination crimp and solder connection, you can also do this. If you're trying to do a straight crimp, you'd want a different type of connector. You could do it with copper, but I mean they make compression style connectors, and they're for use in high mechanical strength scenarios, not high electrical, not a lot of electrical conductivity. The best electrical connection is solder, the best mechanical connection is crimp. If you want to combine the two, you can purchase the $3,000 crimp tool that you'll need to purchase to properly crimp this style wire. You can find some cheap little Harbor Freight stuff for like $100, but it only goes up to 1-aught, and it's not really the proper tool for the type of compression that you need. So just to kind of give you guys an idea. But yeah, I've crimped them on before, I've soldered them on before, I've done both methods. I prefer solder, I'll tell you that up front, just because I know what solder does and I understand how it bonds. But yeah, that's kind of the best explanation I can give for you guys. If y'all have any questions about it, feel free to ask. This is, like I said, the reason I'm doing this is because I have an over-spec wire for a spec connector. Technically, if I really wanted to make this the way I normally solder these, with a vise and actually go into it and dip it, what I'll need to have is a 250 kc mil copper, and I'm not even sure if they make that. So this is too hot to add a heat shrink to. As soon as I add the heat shrink, you can kind of see what will happen. The heat shrink starts to melt on me, and I won't be able to put it on there. So you'll have to wait for that one to cool off while I do the next one. And this is only half of what he needs. He needs a hot connector from the front to the back. He's going to do, on this application, we're going to go LC40. The reason we're going to go that is just simply for a single wire sake. So we're going to run one wire. I'll have to cut this back for all. I wonder if I got something to show y'all. Might as well show y'all something fun while y'all are here. Lots of people in the key down community are familiar with what this is. It's just basically a welding connector. It's used commonly. I prefer another connector, but I don't own or have the option of getting it cheap, and that is something called a cam lock. Those cost about $60 a connector, so it wouldn't be that cheap. But I would try to find for this application, as long as the customer understands what I've explained, the customer would never have any issues with this setup. This is kind of what the next step's going to be. This is not this step. I'd like to show y'all, but I'm running out of time, so I figured I'd show y'all a little bit. You get a double jacketed wire, you're going to have to go crazy like me. I have to cut above the connection size. See, if you look, my size wire is literally the size of this jacket. So I'm going to have to cut it all the way up top, up to the widest part, just to make my wire work, because my wire, again, same thing, over-spec. Going back over here. Don't do that without safety glasses. I got mine sitting over here. I just didn't put them on because I knew what I was doing. But if you don't know what you're doing, you'll sling hot plastic in your face. So just be safe. Don't be it's one of those things, do as I say, not do as I do. I have safety glasses, I just didn't grab them. Alright, so back to this, kind of going into the same scenario. I'll have to stretch this to get it in here, and once it goes in there, it ain't coming out anytime soon. But that's what that connection will look like, just so y'all know. I like LC40 because I like the the cam lock because it has a cover for this piece right here. It's used commonly in no safety concerns. Yeah, no, just that's my disclaimer. My disclaimer is do as I say, not as I do. So that's the best I'll give you guys. There are safety precautions to take. You got to watch where you have a torch. You got to watch what angle you're putting it at. You got to make sure you don't ever put it back on yourself. Basically, all the common sense stuff that you got to kind of keep into account. Anytime you got an open flame, make sure you have it away from you. Anytime you're working with something like this, if you really want to be extra careful, then get you a set of gloves that will handle some heat. Get you like some leather gloves or something you can't burn yourself with. Simple set of rules is if it works in welding, it works in soldering. So all soldering is low heat welding. So you want to take every precaution you need to take, and then go ahead and kind of get the same setup that a welder's got for the most part. Save the eye part. Save the eye part. So accepting that part. This is the last connector on here. This is just the ground right here. This is going to be for his alternator ground straight to his frame rail, and then the other one's going to be from his battery bank. He's got a large set of these. That's what he's got for his battery bank. His are about double this size. Just to give you an idea. Not that small. But two of those I've successfully ran a 24 pill off of with no trouble. So he's got 4, so he's got whatever he needs. He may not use those for the exact application that's been used, but he has capacity to do whatever he wants. So just to kind of give you guys a picture of what can be done on this stuff. And then again, like I said earlier, this is over-spec wire, so yeah, I have to fight the terminal to fit inside. This is a 4-aught terminal. This is 4-aught wire, but they try to go overkill sometimes, and when they do, it makes it more difficult on me, which is not a big deal, but they don't really build any copper terminals bigger than 4-aught. They go to an aluminum style, and when they do that, I mean, it's a little bit more of a pain in the butt for me, because then they turn into, I don't have any here. I've got probably 20 in another location. I brought them all back over there. But they're good for AC, but not good for DC. They kind of fall back on a lighter form of a crimp, which, like I said, I'm not a fan of crimp, to be honest. You have more room for failure, less room for contact, and definitely not a fan of crimp alone. Crimp and solder is fine. I ain't got no problems with that, but you just got to purchase the right tools and make sure you're not skimping on the tool. Because if you get the wrong tool for the job, then it can be a problem. Because then your crimp won't be strong enough to hold the proper mechanical or electrical connection. So here's the next one. About to run myself down on solder, but it is what it is. It's what name of the game of this stuff. It'll eat some solder. Alright. I'm just looking at this connection myself, just to make sure. Alright, cool. There is a set of ground clamps there for you. Again, like I said earlier, this will not heat shrink right now. I can kind of cheat, maybe, if it'll work. I doubt I can, because it's just barely enough size. Let's see if it'll work. This is your best cheat if you have to work on a heat shrink with a hot connector. And we'll see if this fails, because worst case scenario, I got to cut it back off, and I don't really care that much. But just so you know, there you go. There's your quick cheat right there. What's up, Trunk? What's up? What's up, Matt? How you doing, man? there we are. Got a completed set of grounds. Kind of need to check my time. I got a limited time today because I got to get up stupid early tomorrow. I might be back on for a couple videos in the morning if y'all wake up that early. But that's some ground clamps. Y'all can kind of see the concept. Ground's done. Next up is going to be the hot, and I'll get in a minute. Will you hand me that end of that wire, please?
What
She's
end?
showing off her food. Some lo mein something. That one down there.
The big one?
Yes, please.
You the end of it?
No, the one that's got the piece on it. No. All the way around, probably over here, maybe. Where'd it go?
There's nothing
That's the
down
big
here.
fat wire. Hold on, guys.
This one?
Oh, it's not. Yeah, you're right.
No?
Alright. Oh, I took it off. Sorry, guys. This is what somebody for later on. That's a lot. I gotta watch out. My heat shrink's still hot. Yeah, I know. Just to kind of show you the concept of what's going to happen. This shows you just how crazy this wire can get. If any of you guys have seen what an LC40 is, I mean, that's a fairly large connector, per se. But look at this wire in comparison. It's some big stuff. For the application it's going to be used in, it's not going to be used to its absolute limits. So these connectors are more than adequate. And what he's trying to do is eliminate voltage drop. The reason you run a big wire in any application... yeah, waving a hand, cool James. The reason you run a big wire in any application is to prevent voltage drop. If you want to prevent voltage drop, you have what's called resistivity in wire. The higher the resistivity is, the more voltage drop it'll have per foot per amperage that's drawn on it. So that's where that application comes in. So it's not really necessarily your final connection points that's your failure. It's the overall length of the wire that you're using, and also the failure in terminations. So if you don't terminate properly, or if you don't size properly, that's where you have the biggest voltage drop. So that kind of helps you know just a little bit about what's going on. Even though this wire is bigger than this connector right here, this connector is more than adequate to handle this at this length if you run it a short length. So where you'll have problems is if you look, this connector has a split in it. See that split? When that split gets loose and doesn't make enough contact on the base of the connector, that's when you have major voltage drops, whenever your connector starts to fail. Same concept on any of these Andersons. If you connect an Anderson and this connection right here ever gets loose, the tension on that pin doesn't make good enough contact, then at that point, that's when you have failures on Andersons. The way you test that stuff is very simple. It's the easiest solution ever. You're like, oh no, is my wiring big enough? Is this big enough? Is that big enough? What you do is measure the voltage at one end, and you measure the voltage at the other end. Under load. Now, of course, in that application, some of your small test equipment won't keep up. If you want to spend the money on a digital multimeter, you can. You can also do it on a analog multimeter. Or analog meter in general. It doesn't matter what it is. But the higher volt, if you're seeing a half a volt drop from one end of the wire to the other wire, you can go to a bigger wire and have less voltage drop. If you're seeing a 2 volt drop from one end of the wire to the other wire, change the wire. The reason being is because it's having to dissipate way too much heat in order to stay running. So that means that copper is going to get hotter and hotter and hotter until the point where it fails. So don't let major voltage drops sit in any application. You want to try to alleviate that in any way you can. If you have to go a super cap and you can upgrade your wiring, yes, there's benefits for a super cap, and there's a reason it would help. But it has its limits. You can't go crazy with what you're trying to run on it. Normally, this LC40 has a crimped base system. I'm not going to use the crimp. I'm going to actually solder into it. Just so you guys know. I mean, it's not something you guys have to do. It's just what I'm going to do, just because I have the ability to. So that's what I'm going to be doing. From that point, kind of give you a comparison though, this is the biggest type of connector they got, and it's still going to be tough for me to get this connector to fit in here. So it'll be fun. But I mean, anything more, and you're going to have to spend a lot of money on some cam locks. I may start offering cam locks in the future if enough people want some wiring, and that will be properly running the wiring and properly running the connector for as little voltage drop as possible. If you're not worried about that, then continue running this. It'll be fine. You just got to make sure you're not going to overrun your wire where you drop too much volts. Most of the time, it's not really the connector's fault. It's something else. So that's my little technical explanation and then my little practical application video. So I got to go. I'm headed to bed. See you guys later. I will catch y'all tomorrow morning maybe. I'm probably going to do a really nice test on something pretty large to see if it's working properly. So if y'all are up early enough, y'all can see it. I'll catch you guys later.